Good afternoon, everybody. Are we ready to get Plugfest session number 2 underway? Did we all enjoy session number 1? And we have some more tests this afternoon. First, a few administrative details. If you left a cell phone in the grand ballroom, there is an iPhone, and I can give a few details. There's some text messages and other things on the front of it. So anybody knows who might be talking about David Waltz? That's about all I can get out of it. But we have a lost cell phone. You might communicate who it is. We're going to have it on the stand behind the Plugfest area, and we can get it back to you if you can prove that it is yours. So thank you very much with that. Now, for this session of the Plugfest, we're going to go back to Recloser testing. So this will be similar to what we conducted in the first round. But I'm going to do a few more introductions because I asked for feedback. How did the sessions go? Everybody enjoyed some of the technical commentary, but they pointed out that you might have glossed over a few details that are not apparent to everybody, like red is normally bad in the world, and we like to make things that are energized red and not green. So we're going to talk through this Recloser scheme here before we start initiating the screens or initiating the tests in more detail. So I think earlier we definitely talked about the fact that we have our 4 feeder breakers. Those are the ones that are identified there in the corners. Why do we color things on SCADA operation screens as red when they are passing energy? Does anybody know? Anybody want to? It's ouch. If you touch it, it will be red for you. You do not want to be touching those energized assets. So red means it's energized, but if in the concept of flowing power, that's a good thing. So that's why generally, little fun fact, there are a few utilities in the world that don't use this convention. They use the opposite of that. So make sure you understand that before you're engaging with them. But red is ouch, dangerous, but good when it comes to power flow. So that's why we use the opposite colors. The next thing to highlight is if the line is thick and highlighted. So we kind of have the yellow line in the middle with the gray highlighting around the line. That gray indicates that there's power flowing on that part of the bus. So that is energized, actively passing power. And when it becomes de-energized, it becomes the thin line. And that's a pretty common convention throughout all SCADA operation control screens in the utility business. We use a thick line to represent what's going on. There were also a few questions about how Recloser works, so we're going to go through that again, but in a little bit more technical detail about like how do you detect these things and how do we send the controls and what's completely going on in the scheme. Because I had a couple, there are several people here that are saying, I've been in the communications industry forever, and this is my first time being exposed to the power industry. I thought I understood, but I got a few more questions about it. So when energy is flowing from all of these devices, you'll see that we have 4 sources in this diagram. We have 4 substations that are supplying power to this part of the system. It is generally bad to have a networked power system so that we have multiple sources actively connected to devices at the same time, because that makes the protection and control functions incredibly complicated to calculate, to figure, to operate. So generally, we prune the system into a tree in some form, and we put some open locations. So that's what you'll see, those 3 green reclosers that are in the middle of that line. Those are the reclosers that are the normally open ties that are in the system. And in an electrical system, traditionally, if you look at a map of the city, you'll see the lines going up and down the streets. And if you just looked at the map without knowing what the switch state was, it looks like there's a wire on every street, and all of the streets are interconnected. And the reality is that is true, but we have some sectionalizing and tie switches that are open in some form. And those might be manual switches that we have to go out there with hot sticks and operate. And then some of those, a small portion of those, have been automated. And even when you see the sectionalizing diagram, this can be 100 miles of power lines. And between each of these automatically controlled points, there might be 5 or 10 more manually controlled sectionalizing points. So the same thing that we're automatically doing here would be manually done in the field for a technician to even isolate the problem down to just a block or even a customer, depending on where the actual issue is. They'll try to isolate it down as small as possible when they arrive on scene. to talk through a little bit of what's going on. Why do we call something a recloser? So for everybody who's electrical background in this, you'll understand this. But has anybody ever wondered why your lights blink 3 times, but after 3 times they're not coming back on? Has anybody ever experienced that during a storm or a windy day or trees or something? Does everybody know you just experienced a recloser? Those used to be electromechanical devices that were magnetic predominantly. Now we put sophisticated controllers on them, like these blue boxes, and these boxes are measuring the currents and voltage waveforms in real time, and we give them a setting value and say, hey, if you go over this for a certain amount of time, so a time over current function, typically, and there's other functions in there, you're going to do something about that. And we can decide, hey, if it's a really big fault and it occurs really fast, we might do something differently than if it's a small fault that lasts for a longer period of time. In the most simplistic form we see that, we open it, and what the reclosing function did is said, hey, most times when we open up because there's a fault, it's a transient fault. What would be a transient fault that would be out there? A cat, pornographic, squirrel, snakes, animals on the lines. Those are typically transient. They're there and then they're not there. Trees, limbs and trees hitting the line, they hit it, but they eventually fall off of it on their own. We said, hey, we don't want to be out of power for hours and wait for somebody to go out there and manually do something about it. So we're automatically going to do something about it. And the most simplistic form of that is reclosing. And so reclosing is, hey, if I saw a fault and met a few certain categories, if it's a really hard, strong fault, i.e. not a cat or a tree, I'm probably just going to stay locked out. But if it's a transient fault, after a fault occurs, I'm going to wait some amount of time, i.e. your lights go out. It's usually 3 seconds. It's going to wait 3 seconds. Some utilities use different settings. After that, I'm going to reclose the breaker and see if that fault's still there. It's kind of abrupt, so we close the switch, energy starts flowing down the line, and if it is a transient fault, it'll stay closed in and you'll just have your lights blink. If it's not a transient fault and the wire's actually laying on the ground or there's some more significant fault, it will again see the fault current and will open up, but this time it's going to open up quicker and it's going to wait longer, maybe 5 seconds, maybe up to 20 seconds, and then it's going to try one more time. If it tries that one more time and still sees that fault current, it's going to lock out. And that lockout means I'm not going to try to automatically operate anymore. If you're in a substation, there's literally going to be a piston grip handle that's going to have rotated and locked, and you are going to have to go on site and reset that. If it's a recloser, a lot of times we have SCADA controls where we can do that remotely. We can try to remotely control that device. After we've sent somebody to the field, they've inspected the line, they've isolated something, they'll call back in on the radio to operations and say, hey, we think we solved the problem. Go ahead and reclose that breaker and re-energize it. This Recloser scheme is trying to do all of that stuff automatically for us to improve the quality of service that we're providing to our customers. So any more questions about Recloser schemes and communications and networks and how the sectionalizing and operations work? Now I'm going to describe the comms if we're good on the electrical side of what we're hearing. Questions? Any electrical experts want to give a longer dissertation on reclosing? So from a communication standpoint, that function of lockout is important. When lockout occurs, that device is going to send up a message and say, I've locked out. I've seen something on the grid. It's permanent enough. I'm going to lock out. Even during those initial operations, it'll send a message saying I've operated so that you have the logs and you know what's going on out there. But if it operates and then closes back in and all's good, you'll just get the operate command, and that'll just kind of be a log and an entry that says, oh, this happened on the system. We might monitor how often it's happening and where. The key thing that we're getting now is sometimes distance to fault information. And that's really challenging in a branched distribution network, because just because I know the distance to the fault doesn't mean I know where it is, because there's a lot of different pathways. But when you get that lockout, then the automation scheme kicks in. So we have to send in the comm message for lockout. Most Recloser schemes, and I'll ask to confirm this, here in a second that our scheme is going to go check the state of every other device in real time to figure out, is it the way that it was right before the event occurred? Because sometimes two devices will operate at the same time. If we are not well coordinated, anybody know what coordination means in electrical system function? We have to set that time and that overcurrent value. So that makes a curve. And you want to stack those curves, and ideally, they stack such that the one closest to the fault operates first. And that if you have those lines either cross each other or be on the wrong side of each other, what might happen here, if I had an example, let's say we're looking at the time over current value of bus J. We have the normally open J, and then we have I and H. If the recloser between J and I was set slower than the one between I and H, we could have a situation where the IH recloser operates before the IJ recloser does. And at that point, we would not have good selectivity. We operated the wrong function of the grid. We cut off more customers than we actually needed to. We actually had an overcurrent device that was closer. And the reclosers also have their curves coordinated with the fuses that are on the system. So reclosers, here's another common comms function with reclosers, is you might hear them move from fuse saving to fuse blowing mode. So in fuse saving mode, we say it's a pretty day, system's pretty stable. If you see a fault, it's probably a permanent issue. It's not a tree, it's a car hit a pole, and it's a permanent issue. We're going to operate slower, and we're going to let that fuse blow, clear it, and then we'll reclose into it and re-energize most of the customers. We might just have one or two customers off. That's great on a normal day. If the wind starts blowing and you do that, though, you would blow fuses all over your system, and you would have to go out and repair a bunch of fuses. In that situation, we're on the other side of the equation, and it's better we put it in fuse saving mode when a storm's coming. So the reclosers operate faster. They cause a transient for more customers. But when the transient clears, they can re-energize. And most of the time, that's better for the vast majority of customers. So we use comms to switch back and forth between those modes sometimes. It's kind of a big button, even in the control center. They can say, oh, we're going to switch modes, or they can highlight an area, say, hey, for these feeders, we're going to switch modes. We do it different ways for different scenarios. So there's fuse saving, fuse blowing mode, coordination, communication, but we need to confirm the state of all of those devices. So the master station goes out and pulls everybody and says, what is your current operational state? Sometimes they ask you, what was your current load state? Because we have that normally open, and we're going to close and refeed some of the grid from that normally open place. We want to make sure we don't overload another feeder. This could be two really long feeders. And if we have too much load in that area, we wouldn't necessarily want to close into it. Maybe we want to only re-energize 2 of 3 buses because we have more load than we can serve right now. And sometimes we'll check the load. And then the last thing we might try to do is look at distance to fault, amplitude of fault, other things like that, figure out more details about it. But we'll confirm the state of all of that. Then we will do our isolation function where we figure out where the fault is, where it is in the system, which is really a question of, did you see it? Did you see it? Did you see it? You work your way back. So in this case, we're going to work our way back from J to I. No, that recloser didn't see it, but H to I did. Okay, we know the fault is in bus I somewhere in that case. So in that scenario, we've isolated where it is, and then we're kind of back into the scheme that we talked to earlier. We're going to ask J to open, and then we're going to backfeed the energy to restore service. And then the other thing we didn't mention, there's kind of a reverse function to all of this that is done once the repair is made and we want to restore service to all of those customers. Sometimes that's a single button you push that says reverse. Sometimes that's manually SCADA operators going in and saying, and here's an interesting thing, for short periods of time, we will close after we've repaired and the grid's back together. We will feed a bus from 2 ends. But we try to do that for as short a period of time as possible, because if we had a fault during that time, we'd feed, in theory, twice as much current, way more current into that fault than we want to. So Anybody have any more questions on filter schemes and the demonstration and the details of what we're getting into? That has really nothing to do with Plugfest. That is just a little bit of education in the electric power grid. But you can see how important communications are. There's a lot of messages that have to go back and forth. And if you're a control room operator and you start an operation, you cannot move and do anything else in the control room until that operation is finished. And what that operation means finished is either you send to command a switch to change state. And let's think about a manually motor operated switch. You send the command, it will usually acknowledge that it's going to operate, but then it goes into an intermediate state, and then we have to wait for that motor to move these switch blades out of the way. And then eventually we get a signal back that says that switch is now fully open. Now, two things can happen. That switch can fail to fully open, like the jaws of the switch can be bound up and it gets entangled, and the switch is just kind of half open, at which point it stops, and that's a bad state to be in. And so we stop everything and we say, well, we're not going to do anything else with that until we send a technician there to deal with that switch. However, if we have a comms failure at the same time, which can occur more frequently in a mesh network sometimes when you have a lot of nodes in between. If that happens, you get stuck in that same state. It takes a lot more resources to go out and solve these problems. And so we try to not get stuck in that intermediate state. And it could take an operator maybe 5 to 10 minutes to decide if that switch truly isn't going to operate. It'll send a few more commands trying to get it to confirm its state. And if those don't come back, then they got to lock the thing out at the control center. They got to dispatch somebody. That eats up a lot of time in the control center, and they don't like it. And they get really frustrated with automatic schemes when things start to get a lockup and they spend a lot of time operating on it. So if you're doing real-time control, the operators love it when they have broadband networks and they get positive confirmation within. They send the command, and a second later comes back and says, yes, I'm operating. They still have to wait that maybe 30 seconds if it's a switch before it comes back and says, yes, I finished my operation. I'm moved into that final state. But they at least more comfortable that it's happening. And if they don't get the message back, they can pull in real time and it says, yeah, I'm truly open or I'm still operating. So a little more background on broadband networks. With that, we're going to get over to the actual test and talk about what you're going to see in this demonstration. And I say with that, we're going to show the test, but let's set it up a little bit more. What is different in this test?
All right.
That we saw before?
What's different this time is we are now on, if you see the blue token bottle, Nokia is operating on 900, and then the rest of the CBRS is up mainly on this one here. We're on Motorola CBRS, I believe. So that's the big difference, is we're just trying to see, now with Nokia up, we're doing a similar thing, testing different UEs on 900, different UEs on CBRS. Other than that, it's the same that we did this morning. So we'll go ahead and fault zone A. Yeah. So when we fault zone A again, just like we saw before, we'll see that, and we're expecting that to isolate, and now we'll be closing to restore power, and then that shows that that ABB UE works over Motorola's CBRS.
Awesome. Session number one and session number two complete.
Yeah, and so we're gonna, I think we're gonna have more speakers, right?
Yep, we're gonna
So
keep
we're gonna
running
keep
these
testing.
tests. So what you're gonna see is what we did this morning, full complement, UEs against a new RAN provider. And while they're running through each of these tests, we're gonna start calling out some various radio vendors and have them share a little bit more about their devices. But I got to find my Prozac first to find out who we're bringing up here. Actually, I think we're going to have Mauricio come up from Nokia and talk about the Nokia platform since they're providing the 900 megahertz right now. And we'll keep running the test here. So turn it over to you, Mauricio.
All right, thank you very much, Matt. And thank you everybody for joining us here in the test. We've been working with utilities for a while, not only providing the connectivity on the field area network, which is what we're testing now with multiple vendors actually, which is great. but also providing the connectivity for all the entire backend, which is really what you see connected here all the way to the data center where the SCADA systems and answer systems would normally be. So everything that we see here, which is being controlled and is controlling all that, goes to a massive network of what we call a wide area network, typically using IP together. So a lot of utilities have been doing this for many years. As a matter of fact, I used to work in a utility up until like 5 years ago. OG&E was the utility I worked for doing network and security architecture. That's where I picked up most of how things really work out. The explanation they gave about the Recloser was awesome. I love it.
Got a full dissertation in electrical distribution system operations.
I never heard that clearly explained, so kudos to you. And
Next, we're going to do network power systems, a little bit more complex.
Teleprotection, please. That would be
Okay,
great.
we can do teleprotection.
So I think that's that's what's coming down the pipe, right? It's looking at those use cases that are going to move more into the really low latency, into the actual reactive network, and potentially into more of the innovation, automation that the Industrial Revolution 4.0 is bringing. That is something that I don't know if you mentioned yet, but it's something that we've seen a lot now going into utilities, is trying to automate everything. Since now we have the intelligence to do it, as it's shown here, where the network itself is self-healing. As you move on more into the transmission side of the house, or in other applications, you're seeing more and more of machine-to-machine communication. And that's very important for utilities, as you're taking away the human factor that in some cases may result in another or major problem. I think Matt mentioned somebody has a big button that has to push on in order to make this work. Well, sometimes pushing that button requires the proper knowledge, and in cases in which you have disasters or you have to react quickly, that decision may not be clear. So moving into more of the automation into the Industrial Revolution 4.0 requires that we move on to having more and more communication, more machines talking, providing, in this case, connectivity through CBRS and BAN8 with the core right now in the data center. But as we move into 5G and we're seeing more of the applications evolving on the electric utility side into expanding out in the far edge, it will be very important to continue deploying them. So I think events like this are very important because not only we're testing, we're validating the communications, but also we're seeing where things are going to be moving in the next year. So more than happy to be here and participate in this event. You guys are more than welcome to come and ask questions. Our setup is here, where we're showing band 8 and band 48. So this is Antarctica, this is CBRS, and the core that we have out here, and all the connectivity that we provided. So again, if you have any questions, I'm more than happy to answer.
Thank you very much. Maybe pointing out just a few more things in your rack setup here, since it's exposed, you can see it out a little bit more. The device down at the very bottom is the baseband unit for these two remote radio heads are talking, I believe, fiber in both cases, back to that baseband unit. You would see that bottom piece of equipment and these two white pieces of equipment out at a cell site. So if you ever wonder what's in the cabinet at the bottom of the cell tower, it's one of those, plus a site router. I don't know what you're using for your site router.
Just a little box.
Little box in the middle. But that might be a traditional IP router at the site as a site router, any traditional telco demarc device. And then you would have one of these baseband units can support many different sectors. So if you had 3 cell site sectors, and you could have 2 or 3 different bands, you could have 6 or 12 of these radio heads connected to one baseband unit. So giving you a little bit more exposure. We hadn't talked about that over here. If Motorola wants to walk us through how that's laid out in the rack, since we already just that equipment, we could talk about that as well. There is a very clean installer. They got everything kind of in one unit there. But that's a typical install that you see at a cell site, so give you a little bit more familiarity with that. And then I believe you're using the server right on top of it to be, that's the server that is running all the virtual machines that are running all the core functions. So at a small scale, you can run an entire core on one computing platform. You have to have all the different logical elements, but they can all run in virtual machines in one physical device. So anything else to add to that? Or we
No, thank you. Actually, you did my job for me. So thank you very much. Appreciate it. And I think one of the things that it's important to just add on to that is that you don't have to have one of these units in every single tower site. Their interfaces, the optical interfaces can run up to 15 kilometers. So this is something that's called the super, and then you can actually run one centralized location and deploy sectors within a 15-kilometer diameter, so 10 miles. So that's something that we've been doing for many years now with carriers. We actually deploy that way. So that's something that I just wanted to.
That's how a lot of small cells work. There'll be a macro cell site in the area that'll have the baseband unit, and then they'll be deploying over fiber to all the remote radio heads that are on all of the streetlight poles. You know, like how is it just a little white box with an antenna? Sometimes the antenna, like this one here, the antenna is directly built onto the front of the remote radio head, but you really just need this, and then the fiber connections going back to the baseband units. And it's a very typical way that cell sites are deployed down in the small cell world. But in the utility space, we can also use that if the cell site's within 10 miles from a macro standpoint. You could have a full tower and just have all that would be at the base of that is probably batteries providing backup power then for the radio head, so they'll continue to operate if they lose their local source of power. So thanks for that explanation. We'll, if you'll hand the microphone back to Jeremy, we'll check in on status updates here before we jump to our next segment. Looks like we moved on. We left test at test 2. We're now on to test 5.
Yep.
I didn't see anything interesting really happen while we were working on it.
Everything's going great.
Man,
So it's less interesting.
uh-oh.
Now, so this issue is not an issue actually. So because the way the test was running, this is a radio that needs to be manually forced over because it was in 2 tests.
Okay.
So he's forcing it over, and that looks like he already did. So it's on 900 now, and now we can run these tests.
Awesome. Any questions at this point? If no questions, we'll continue testing, and we're going to ask Multitech to come on. Rick Nozell. Didn't want to just say that, and I'm reading from a long way away from the back of the room. Yes. Fair enough. We'll hand you this microphone. Got it. So, share a few things about what Multitech's demonstrating today.
Thank you, Matt. Hey, good afternoon, everyone. Multitech is really pleased to be participating in this Plugfest pilot. Judging from some of the results we're seeing this morning and again this afternoon, if this is a pilot, then we can hardly wait for what's in store for the future. This is just such an exciting time for the energy industry more broadly, and specifically the electric utilities. You might have known I've been around for over 20 years in this industry, and I have watched multiple failed attempts at obtaining broadband spectrum for this industry. But as we stand here today, never thought I would hear it, let alone saying that private broadband is a reality for the electric utility industry. So just unbelievably exciting. Congratulations go out to our friends at Anterix for navigating what appeared to be an impossible maze of bureaucracy and other issues that they faced. Yet they went through it, and almost simultaneously, our federal government was kind enough and innovative enough to bring their biggest innovation that we've seen in frequency spectrums for as long again as I've been here with CBRS. So 2 incredible options for utilities that didn't exist before, and that is really quite exciting. I'm also struck by the brands that are participating in this event, right? From Ericsson to Nokia to Cisco to Motorola. It's telecom royalty, right? And they have obviously products that are ready to deploy today, probably a little bit ahead of the curve for the utility business, but I think we're going to be seeing quite a release of all the pent-up demand that has existed in this industry for far too long. So, Multitech, our brand is not quite as recognizable as those 4 brands by any means, but we have been connecting critical assets for over a half a century. We design and manufacture all of our product out of our headquarters in Minneapolis, Minnesota. And we have a broad portfolio of different connectivity solutions embedded. We have UEs, which we are demonstrating here, gateways, and we look forward to working with all of you. Thank you.
Thank you very much, Rob. So, So we're moving right along through testing. We have finished tests 4 or 5. And
This is the last one.
This is the last test here. Will be finished in a few moments. While they're finishing up that last test, we can go over what all radio equipment, bands, and UEs were used on this. So we continue to build out the portfolio of successful tests here. So if we go to our success screen over here, during these tests, we're now running on Nokia's 900 megahertz platform. So you can see we've tested with, in all of these different scenarios, we tested with all of the different UE device manufacturers that we have in place. As well as during these tests, you'll see that we've added to our CBRS portfolio. We've tested all of these devices as well on Cisco, Ericsson, and Motorola CBRS. So whoever's on 900, we're testing the other complemented devices on CBRS. So in both of the sessions today, you've seen us test Motorola and CBRS on Nokia across this entire portfolio. And now in today's afternoon session, you've seen us test with Nokia on 900 full complement of vendors and CBRS on, or I guess the other half of the RAN devices that are being connected. And with that, I'm assuming since we built the screen, we've finished that test. Next, I'm going to ask Adam Nathan from Worldwide Technologies to come up and share a few moments. And after that, I think we're going to celebrate the schedule a little bit and then cut to a workforce demonstration from Southernlink. We'll be about 10 minutes early with that. So the floor is yours. Yes.
Thanks, Matt. Thanks everybody for just an awesome week. So I lead WWT's utility and energy practice. So engaging with the larger OEMs around the country, and it's been a pleasure to work with John Hughes and Amron here as he's really been a pioneer, and really appreciated that partnership. But it's, this whole event is a unique, it's just so unique to this space, right? It's no other industry. You're not getting Home Depot and Lowe's in a room together to figure this kind of thing out. It is critical to society that this does work and that we do make this progress, and so being a part of it is I think everybody said it a bunch, but it's just such an exciting time in this space. Worldwide, we're working with all of the various vendors. We've got a lab. We're headquartered here in St. Louis. A systems integrator, and a big partner to most of the OEMs here, and really just wanting to continue to work with the industry to continue the testing between now and the next Plugfest, and work with this organization to figure out what are those things that we need to test, so that when we get to the next Plugfest, we're showing what we've learned, and it's really taking the time in between them to advance the industry. So I look forward to working with you all. Moving forward, we have here today, the Cisco demonstration is running off of a core in our lab that's about 20 miles away.
I was going to mention this, how the core is working for Cisco. So yes, please cover that.
Yeah, absolutely. So we have our lab is it's about between $500 million and $1 billion investment over the last 10 to 12 years. 500 racks of gear in 3 buildings. We have an RTAC set up from SEL with every core here is either in there or on its way, and we're working on, and we've got, it was the RTAC, some substation monitoring solutions, really and then on the other side, every major cybersecurity platform. So not only can we test do things work, but how, if you put a new device on the network, how do those different platforms actually identify, classify, and report back on, set a baseline for that traffic and report back on the activity. So as we continue to progress here, looking at use cases across the spectrum, unintended, I guess, we want to continue that testing of the full intent solutions through the year.
Yeah, maybe to walk through just a little bit of the logistics. So we will highlight another rack here and how equipment is working and how things look a little bit differently. So if you remember, this is the Cisco CBRS antenna that you see here adjacent to us. That is coming down an UE Ethernet cable being fed out of this red cabinet. This red cabinet has less equipment in it than you see with some of the other installations, and that's because the core they're connecting to is in Worldwide's data center. And so what you're seeing here is really the device providing power and connectivity, and then the site router that is providing the tunnel from this facility over the hotel's internet connection out to the internet and out to the data center where we're getting those core functionalities, and it's also from the data center where they're reaching out to the SAS to get their coordination for this device. Anything else to add?
When that environment is available to anyone at any time for free. So you just a corporate email address on our website, you can find that and you can launch an environment to play around with it. And we work really closely with Cisco on that to get that up and running and welcome that. We're really just trying to get the technology in people's hands. So it's sort of Plugfest year round, and would love to work with anybody that has any questions or thoughts about it.
So at UBA, we're going to call those test beds.
Yes.
So Plugfest is an event on top of the
All right.
test bed. So we've already got our first test bed up and running that you have access to Cisco's core here, and you could get a radio device, take it to your facility, get it set up and tunnel back to that core and be able to show CBRS demonstrations. So you too can have as much fun as we've all had here this week, getting everything up and running. So,
And if you buy now,
we got a deal for you.
yeah.
The after the show, these guys know. Next, we're going to have Southernlink come up. Tom is joining us to give us a demonstration live off of their system and operations to show some workforce management applications. So we're moving a little bit from the testing aspect here to this is a demonstration of some of the technology that they're running over private LTE. So Tom, take it away.
Hello, everybody. Welcome. My name is Tom Beddix. I manage our network operations team with Southernlink Wireless. Southernlink is a part of Southern Company. We've got operations in our traditional Southern Company footprint, which is the state of Georgia, state of Alabama, and southeast Mississippi and northwest Florida. So we've got over 1,300 LTE sites that are up and active today. And we've had some great demonstrations of some fixed data applications. We're actually running Recloser on our network today over LTE. We've got transmission line devices, distribution line devices, SCADA, all live and active on our network. I'm going to be demonstrating an automated resource management system. It's really a work order management system that we've developed, and it's used by our transmission crews, our distribution crews, to manage their work order. So just to give you a little bit of a background on that, since about 2018, we've had enough LTE sites in our network to be able to support mobility from both a voice perspective as well as mobility from a computer perspective. So we've been doing this since about 2018 on our LTE network. I am roaming right now on currently it's on T-Mobile, so I'll be working over LTE. I've got a band 26 modem inside that computer that connects to Southernlink, and then it can roam on all the tier 1 bands once we're out of the network. The transmission distribution work orders are sent to this computer. So these would typically be a tough book that would be in a distribution or transmission line crew's truck. They're mounted in their truck. As they start up, they turn up their truck in the beginning of the day. And I'm just kind of go through what they would go through in terms of their trouble tickets and how that works. The trouble tickets get here in a few different ways. One is Remedy, which is our customer service uses that to create trouble tickets. When those Remedy tickets are created, they can be generated to the actual, there's an interface that connects Remedy to this resource management application. And that work order will show up on the distribution truck's screen. It's also tied in to some transmission management systems and distribution management systems. So work orders can actually automatically be generated due to faults or something that happens in the network. Today, there's priorities put on the tickets. I'll show you that. But our next step is to, and that's not done yet, but is to really order the work order so it'd be most efficient for the transmission or distribution truck to go work. So it would look at where all the tickets they have to go work that day, and let me route it so it's the most efficient and fastest work day for that employee. So without further ado, I'll go through some examples. Whoa, it's about as far as I can go. Let me see if I can get out of the reach here of the screen. Give me 1 second, I need to log back in. So when you first log in at the beginning of the day, it comes up with this screen, and it comes up with a contact phone number. So this is used for safety purposes. The crew person wants to make sure that the phone number they have in there is correct. There's a panic button I'll go through with you, but just so the dispatcher knows if there's an emergency, how do I contact this employee? So my contact information is correct here. I'll just hit OK. And here's my work orders for the day. I've got quite a few. I'm connected to a test server. So they just created work orders throughout the Southern Company footprint. Typically, if this was a work order for a distribution crew, of course, it'd be like a Metro Atlanta, it'd be a localized. These are kind of spread out throughout the footprint. So I start my day. There's different priorities for the tickets. I can click on and get more information. First thing I want to do is where is the job I need to work? It says 107 Steeplechase Road. I don't really know where that is. I hit directions, and I actually got GPS coverage in here. Ron Brady, great job hanging up the GPS antennas. But it shows me here in St. Louis. It gives me directions to get to. It looks like Metro Birmingham to work on this ticket. I can actually click all, and it'll pull up all of my work orders. So this is obviously spread out throughout a few states. Typically, this would just be in a metro area.
Tom, could you talk about some of the things that you're able to do in this platform because you had broadband and private LTE that you didn't have prior to deploying such a capable network, either where you were on public or you were using some narrowband communication over the IDM infrastructure? Like, what was fundamentally different with more communication and connectivity?
Yes, we've actually been doing this for over 20 years now, mostly over narrowband network. We had an IDN network prior to this, and things like being able to include diagrams, things that would require broadband, so diagrams, maybe circuit diagrams, could be, I'm trying to think of the other things that they've done in terms of using broadband. The directions is new. We're now able to do real-time driving directions with the narrowband. Those are probably some of the, in terms of just this automated resources, are probably the biggest things that we can do now is look at circuit diagrams, look at pictures of a site, so the person can kind of look at what am I going to be getting myself into ahead of time. Those are probably the few of the big things that are different. So once the worker can look here, it looks like this is a basic inspection that I do, triannual inspection. I can get more details of the ticket. I can expand this window to get more about what I need to do when I get there. And I'm gonna go ahead and accept this ticket, so I'll hit next. And now it says en route. So the customer service representative can know that I'm en route. The dispatcher knows I'm en route going to the actual event. And the dispatcher can actually look at, let me pull up another screen. Dispatcher will know where all the trucks are that are out and about. So tracking the distribution and transmission crews, I know where the folks are. If I get a new ticket, I can route the most efficient person there, but that's manual today. We want to automate that. So I'm en route, I arrive, and it says I'm on site. What I want to do then is put some details on what I've done. So I can click in here and just replace to relay. Our distribution and transmission guys are a lot more verbose typically on what they're going to write, but just for brevity's sake. And then I can click the status to resolve and no further action required. If I click on, if I say this and click next, that'll close the job. Customer service rep can know if this was a, maybe a something for a customer's location, they could know immediately that it was resolved if they get another call. And hit save. And next, and now I'm back up to my work orders. That work order is actually off my work order list now. If there's an issue, maybe with an animal or a person I come in contact with, and there's I can do a panic, so I can do an emergency call. This will light up the dispatcher's console that I've got an emergency, I need help, and they can get in touch with me right away. We've also got the opportunity, if I'm in a work order, to let's say I'm on my way, I need to take a break for lunch. We've got the ability to not on time, and I can just put that I'm on lunch here and how long I'm going to take lunch and hit start. And then our dispatcher as well as customer service agents know that 8 for 30 minutes, he's probably going to be delayed getting to that next work order due to being at lunch or whatever the reason is. That's really kind of it at a high level. It's pretty, I think, simple and efficient work order management system. I think the magic is just on the back end with being tied into our distribution, transmission management systems, as well as our troubleshooting system to get the work orders here in the first place. We also offer voice communications in the truck too. So we've got push to talk that we offer. So we have rugged handsets for our distribution transmission crew guys to use. So they would be able to communicate wirelessly through a VoLTE call or push to talk call to their control center also, or make a 911 call if they had to. So both, I guess, work order management as well as voice communications can be done through our LT network today. Any questions for me? All right. Well, thank you, Matt. I guess I'll hand it back over to you.
Thanks, Tom, for showing that and talking about what are the differences. Work order management is obviously one of the biggest functions that we do day to day at the utility, and has to, or is evolving as the organization changes, and the ability to get, automate, and process that data. Maybe one question that I would have: are you getting more pictures or capturing more high resolution? We'll call it high resolution sensor data, but normally that's a photo. Sometimes it's a scan or some other device as part of the ticketing system, uploading that so you're getting a better understanding of the infrastructure, and then how does that relate to GIS and their ability to get that on a mobile terminal?
They are doing more high resolution images, and really outside of, I think probably the biggest change is outside of this resource management system, they're able to do training, so safety training, other things to the computer. So maybe not inside that application itself, but being able to use our LT network to do training, to do other things, so the operator can go straight from their truck. Sometimes they can drive them home versus having to come into a facility. So, being able to do training, other things like that remotely is a big help for them. And we've talked about some of the issues. A lot of our, workers live in very remote areas. So some of the struggles with, getting good broadband at the house. So being able to use our LT network to do kind of just normal work duties has been a big help for our linemen.
That's a great perspective. I hadn't really thought about it, is how it could benefit them in the rest of their time, or even when they're getting called out, they get more information about the call before they're even necessarily getting on the road. So,
Yes.
thanks very much. Any other questions, comments? Friends asking hard questions. So I'd like to say thank you so much to the entire team that has pulled this off. I said at the beginning of the day, keep in mind, since Monday at noon, most of the people that you see sitting up here at the front of this room, and Matt Ashbeater and a few others, have not left this room, it seems like, that entire time. They've been in here working, making sure things are working. I don't even, if you notice, even how much smoother things went this afternoon after we gave them a little break to optimize some things, like we got some scripts, check some things. They've been optimizing this process. I want to give a big round of applause to the entire team up here. You guys actually want to get out behind the curtain, now that he's been away from the corner. And so thank you very much. We are finishing up a little bit earlier, so Bobby always has the next thing on the agenda. So does everybody know what that is? We'll start with drinks because we're going to go to Budweiser's Brew House, which is literally a block south of the hotel here. So if you walk out this side of the building, 6:30 p.m. So you're going to jump the gun a little bit if you're leaving right now, but the event starts at 6:30 p.m. We'll have dinner, drinks, socialize. I was at the 360 bar last night, so they literally picked us up and well, almost threw us out of the bar, but they definitely did usher us out of the top of the bar. I hope everybody has a good a time tonight as they did last night. Enjoy the company, have great conversations, enjoy some good drinks. Thank you guys for coming to Plugfest. Thank you guys today for coming to today's sessions. We have a full day of this tomorrow. We'll do 2 more sessions. We have more demonstrations with some other technologies, some more failover tests as part of Plugfest tomorrow. And stay for the end of the day. We have some awards for participation and technologies that we'll be handing out at the end of the day. So I think this concludes the program for today's UBBA Summit. See everybody at dinner and enjoy some drinks. See you guys in about 2 hours. Talk to you later. Are you going to try this on?
Yeah.